this video, I'm going to talk about determinants. Determinants are essentially a way to associate a number to a square matrix. And if our square matrix is A, then we can denote it by det of A, or these things that kind of look like absolute values. So instead of square brackets on my matrix, I'll put vertical lines. And I'm going to start with the 2 by 2 case, and then we'll look at higher cases. So if I consider a general 2 by 2 matrix, like I said, these vertical bars indicate that we're doing determinant. The determinant is AD minus BC. We multiply this direction and subtract multiplying this direction. So let's look at some examples of this. For my first example, I want to look at the determinant of this matrix 1, 3, 2, 6. So we start by multiplying this way. 1 times 6 is 6. Minus, and then we multiply this way. 3 times 2 is 6. So in this case, my determinant is 0. If I look at the matrix 3 minus 4, 7, 1, multiplying this way would give me 3 minus multiplying this way, which is negative 28. So this is the same as 3 plus 28, or 31. So determinants can be positive, negative, 0. They can be fractions or decimals. They can be any real number. Before I talk about the determinant of larger cases, I need to define this idea of minors and cofactors. We're going to let A be an n by n matrix. And I want to define the ij minor of A, which I'm going to denote by A sub ij. If I want the ij minor, I'm going to delete row I and column j. If we do that, we're left with an n minus 1 by n minus 1 submatrix, and this submatrix is the minor. Next, I want to look at the cofactors. The ij cofactor is denoted by C sub ij, and it's given by the ij cofactor is equal to negative 1 to the I plus j times the determinant of A sub ij. So this negative 1, the sign of this determinant, depends on the position that we're looking at, the particular position that we want, and then we take the determinant of the minor. So let's look at examples of these. So here's a matrix A, and I want to find A13 and C13, so both the minor and cofactor corresponding to the first row, third column. So let's start with the minor. And if we're looking at minor 1, 3, so the first number is the row right here. The second number is the column right here. And we're going to delete those and look at what's left. We have a minus 4, a 3, a 0, and an 8. And that's it for the minor. The cofactor is defined as negative 1 to the I plus j, so 1 plus 3, times the determinant of what we just found. This is negative 1 to the 4th. And this determinant, multiplying this way, gives me minus 32. And multiplying this way gives me 0. So my solution would be negative 32. Using the same matrix, I want to find A21 and C21, so the minor and cofactor corresponding to the second row, first column. So this time I'm going to get rid of the second row completely and the first column. What I have left is 7, 6, 8, and minus 2. So that's our minor. The cofactor is going to be negative 1 to the 2 plus 1 times the determinant of this submatrix that we just found. So this is negative 1 to the 3 times multiplying this way gives me minus 14, minus multiplying this way gives me 48. Negative 1 to the 3 is negative. Negative 14 minus 48 is minus 62, so our solution here would be 62. I'm now going to let A be a general n by n matrix, and this time I want to be able to find the determinant of this general matrix. And a determinant is found by a cofactor expansion of a row or a column. So I'm going to use this idea of cofactors to find my determinant. The first step will be to pick a row or a column that we want to use. If you have a row or a column with zeros in it, that would be ideal. If you don't, you can pick any random row or column. I then look at each entry in either that row or that column and multiply each one of those by its cofactor. So I'm going to find each cofactor in that row or column and multiply those by the entry in that row or column. We then add these numbers up, and this gives us the determinant. And whenever we're dealing with this cofactor, we noticed it had that minus 1 to the I plus j. I don't want to have to keep thinking about whether things are positive or negative, so I'm going to give a general form to figure this out. This first entry right here will always be positive since 1 plus 1 is 2 and negative 1 squared is 1. The next entry will be negative, positive, negative, etc. As I go down, I'm essentially going to use a checkerboard pattern to figure out the appropriate sign of the cofactor in each case. And we can expand this checkerboard to as big as our matrix is. So let's look at some examples. I want to start with this matrix right here. And we need to pick a row or a column to expand down. And I'm going to start by expanding down the first row. In order to do that, I take my number in that row or column, which is 4, and I multiply it by its cofactor. Like I said before, the sign of the cofactor depends on the position. And the very, very first row, first column is always positive. So this will be plus 4. We then delete that row and that column. And we need to take the determinant of what's left. So the determinant of 3, 2, 1, 4. From there, I go to my next entry, which is a 2. Once again, the sign of the cofactor started with positive and checkerboarded out, so this one will be minus 2. And then we delete that row and that column and take the determinant of what's left. 1, 2, 3, and 4. Finally, I go to the last entry in that row, which is negative 1. When I checkerboard out, this was a plus, a minus, and a plus, so I have plus negative 1. And then I delete that row and that column and take the determinant of what's left. 1, 3, 3, 1. And from here, we just have a bunch of 2 by 2 determinants. This would be 12 minus 2. This next one would be 4 minus 6. And this last one would be 1 minus 9. So this is 4 times 10 minus 2 times negative 2 minus negative 8. That gives me 40 plus 4 plus 8 gives me a determinant of 52. Now let's look at this one. This one's obviously much, much larger, but we notice it has a lot of zeros in it, which makes it not so bad. I'm going to go down this second column, mainly because it has 4 out of 5 entries as a 0. I could have done the same thing with the second row here. It won't matter either way, but in this case, we're going to look at this column. As I start, I have the entry 0 times the cofactor, but 0 times anything is 0. So I'm going to ignore that term, as well as this term, because once again, it's just 0 times something, and move to this 4. Well, when I do my checkerboard pattern, this is a plus, minus, plus, minus. So this would be in a -4 position. We then need to delete that row and that column. And we want the determinant of what's left. So this is still a pretty big matrix. -5, 7, 0, -3 for the first row. 0, 2, 0, 0 for the second. -9, 6, 7, -9 for the third. And 3, -5, 0, 0 for the fourth. The other entries in this column are 0, so this here is the only term I need to be concerned with. And now we need to take the determinant of this. We're still going to have -4 times this next piece. Once again, I need to pick a row or a column. Since I did a column last time, I'll do a row this time. And this second row has a lot of zeros in it. Equivalently, I could have looked at the third column. So I have a 0, a 2. When I look at signs, this first entry is positive, this would be minus, and this is positive, so I get a +2. I then delete that row and that column, and I take the determinant of what's left. -5, 0, -3, -9, 7, -9, and 3, 0, 0. So once again, we're getting better and better. If we scroll down a little more, we now know this number out front is going to be -8 for 4 times 2. Once again, we need to pick a row or a column to expand down. I did a row last time, so I'll do a column this time. And once again, this one has a lot of zeros in it. We could have also done the third row. So I have a 7, and if I look at my checkerboard, this is a plus, a minus, and a plus, so this is a +7. And then we can delete that row and that column. And when we do, we're left with -5, -3, 3, 0. We know -8 times 7 is -56. And when I look at this determinant, I have 0 minus -9. That leaves me with -56 times +9, which gives me a determinant of -504.